All right, hello again, everybody. Today we're going to be talking about properties of exponents and what we can do with these sorts of things to simplify polynomials in the future. So the first rule that we have is this product of powers rule. So this says if we have an expression of the form x to the a times x to the b, where x is the same variable or the same number, we can take the two exponents a plus b and add them together. So we can have x to the a plus b. So let's take a look at this first example down here. We have 2 to the third times 2 squared. So one way we could have solved this in the past is we could just write everything out. So 2 to the third we know is 2 times 2 times 2, which is the same as 8. And 2 squared we know is 2 times 2, which is the same as 4. So we could take and substitute 8 times 4 in for those values, and we know 8 times 4 is 32. But using this new product of powers rules, since these 2's are the same number as our base, we can now take and add the two exponents together. So 2 to the third times 2 to the 2 squared becomes 2 to the 3 plus 2, which becomes 2 to the fifth. And we can check and see if that's 32 like we got above still. And we can write everything out, 2 times 2 times 2 times 2 of 5 times. And that is going to end up equaling 32. So what this allows us to do is it saves time if you remember that 2 to the fifth is 32, but it also minimizes multiplication errors when multiplying these sorts of terms out. So let's look at the second equation here, or the second expression here, excuse me. We have x to the fourth y squared times x to the negative 2 y to the fourth. So we can still use the product of power rules here, but what we'll have to do is we'll have to evaluate our x's and our y's separately. We'll take the like terms. So with our x's, we have x to the fourth times x to the negative 2, and that's the same as using our product of power rules, x to the 4 minus 2, or I should rewrite this as x to the 4 plus negative 2, which we know is x to the 4 minus 2, which is x squared. With our y's, we can do the same thing. We'll have y to the 2 times y to the fourth. And using the product of powers again, we'll have y to the 2 plus 4, and that's the same as y to the sixth. So our answer, our simplification of this expression is x squared y to the sixth. So the product of power rules just lets us save time with some of these computations, and it also lets us simplify some of these expressions. And likewise, since we had a product, a power products rule, now we have a quotient of powers rules. So this says if we have x to the a over x to the b, we're going to have x to the a minus b. This time, instead of adding the exponents, we're going to subtract them. And here it's important to note x cannot be equal to 0, because if x is equal to 0, we have a 0 in the denominator, and we can't have that. And that's true for any variable, not just x. If you had like y to the a over y to the b, y cannot be equal to 0. So let's go ahead and check out this first example here. So we have 3 to the fifth over 3 squared. So in the past, what we could have done was we could have written out every term here. So 3 times 3 times 3 times 3 times 3 over 3 times 3. And then we could have crossed out our like terms. So we could cross out 2 on top and 2 on bottom. So we're left with 3 cubed, which we know is equal to 27. But with this new quotient of powers rules, we could take 3 to the fifth over 3 squared and subtract our top our bottom term from our top term to be 3 to the 5 minus 2, which is the same as, we know 5 minus 2 is 3. And that is the same thing as 27. So these equal, our old way and our new way give us the same answer, but the new way with our quotient of powers rules minimizes, again, the chance that we accidentally cross out one too many terms or we forget to write down a term. So we can still do this with variables as well. So here we have 3x to the 7th over 12x cubed. So what I like to do is I like to separate our numbers. So we have 3 over 12, and then I'll separate the variables. So here we have x to the 7th over x cubed, and I'll work on these individually. So we know 3 over 12 reduces to 1/4, and now with our x to the 7th over x cubed, we can use our new quotient of power rules. So we'll just take x to the 7 minus 3, and 7 minus 3 we know is 4. And now we'll combine our terms back together to get x to the 4th over 4 is the simplification of that expression. So these rules allow us to save time while simplifying these expressions. So next we also have the negative exponent rule. And this says that if we have x to the negative a, that's the same thing as 1 over x to the a. So you can flip it down into the denominator to make it positive. And this is the same as x to the negative a over 1. And likewise, you can, if you have a negative exponent in the denominator, you can flip it up to the numerator. So 1 over x to the negative a is equal to x to the a, and it becomes positive. And again, since we're dealing with a denominator, x cannot be equal to 0. That's the only stipulation for this rule. So let's look at this first one here. We have 3x to the negative 6. Well, using our negative exponent rule, what we can do is we can flip this x to the negative 6 to the denominator and rewrite this as 3 over x to the 6th. That becomes positive. So that would be our simplification. It's important to note that this is not 3 over x to the 6th. This 3 does not flip down to the denominator. Why is that? Well, this 3 has its own separate exponent of 1 that's attached to it. So the exponent of the 3 and the exponent of the 6 are different. So we can't just see the 1 negative and flip everything to the bottom. You're going to have to look at each individual term. So let's go ahead and evaluate this next example. We have x squared y to the 8th over x to the 6th y cubed. So like I did in the last one, I'm going to break this up into our x's, so x squared over x to the 6th, and our y's. So y to the 8th over y cubed. So working with the x's here, if you remember our last rule, it was the quotient of powers. What we can do is we can rewrite this as x to the 2 minus 6 by that quotient of powers rule, and that's x to the negative 4. We can do the same for our y's here. So that will be y to the 8 minus 3, and that's the same thing as y to the 5th. So our answer would be x to the negative 4, y to the 5th, but when we're simplifying these expressions, we can't have a negative exponent in our answer. So what we'll use is we'll just use rule 3 here and flip that negative exponent to the denominator. So we'll flip that down, and we'll have y to the 5th over x to the 4th. So always make sure that if you have a negative exponent, you flip it either from the denominator to the numerator or the numerator to the denominator to make it positive. The last rule that we're going to go over today is the 0 power, and this just states that if you have x to the 0 or anything to the 0 is going to equal 1. As as long as it's not 0. So if we look at this first example here, we have y to the 0. Well, sorry, y to the 0, brain fart, 7 to the 0. So 7 is not equal to 0, so this is just going to be 1 using this 0 power rule. So let's look at the second example over here. We have 6x to the 0 y cubed. So let's go ahead and use the 0 power on this. So we'll have 6 times x to the 0 is 1 times y cubed. And that's just going to be the same as 6y cubed. And just like the last example we had, that 6 has its own its own exponent of 1, and the y has its own exponent of 3. So just because you see 1, 0, that doesn't mean that the whole thing is 0. You're still going to have to look at each individual exponent. So now let's go ahead and simplify the following expressions. So looking at the first one, we have 3x to the 5th, y to the negative 2, times the quantity negative 6x to the negative 2, y cubed. So I'm just going to break this up like I have been doing. So let's take a look at our numbers. So we have 3 times negative 6, and we know 3 times negative 6 is negative 18. Now we'll take x to the 5th times x to the negative 2 times x to the negative 2. And if you remember back to our first rule, our product of powers, when we multiply these two terms together, we're going to add the exponents. So we're just going to take x to the 5 plus negative 2. 5 plus negative 2 is the same thing as 5 minus 2. So this will be x cubed. Lastly, we're going to work with our y's here. So we have y to the negative 2 times y cubed. And using the same product of powers rule, we can write this as y to the negative 2 plus 3, which is the same as y to the first. So let's go ahead and combine everything back together. So we'll take this negative 18, this x cubed, and this y. And so the simplification of this expression is negative 18x cubed y. So this last expression over here, we have the quantity 4x squared plus 7x minus 2 minus the quantity 3x squared minus x minus 5. So let's go ahead and distribute this minus sign through first. So when we distribute it to our 3x, it'll become minus 3x squared, and we flip our term in the middle to make it positive. When we distribute it to our minus x, it'll become plus x. And when we distribute it to our minus 5, it'll become plus 5. So now, in order to add these two expressions together, we need to group our like terms together. And our like terms we do by our variables here. So this x squared term will get grouped with this x squared term. The x term, which is x to the first, it'll get grouped with this x to the first term, and then we'll group our two constant terms together. So this will be equal to, when we group them together, it'll be 4x squared minus 3x squared plus, our next grouping is 7x plus x, and then our last grouping is going to be negative 2 plus 5. And now we can go ahead and evaluate these expressions. So these variables here, x squared, since they're like terms, we're going to keep those the same. We're not going to do, how I should say it is, we're going to take 4x squared minus 3x squared, and we're going to subtract the coefficients here. So we're just going to be left with an x squared term. And we're going to do the same for this 7x plus x. We're going to add the coefficients. So we'll have 8x, and then we're going to add our constant term. So negative 2 plus 5 is going to be plus 3. So the variables don't change. It's the coefficients that you're going to be adding or subtracting in any given problem. Don't change the exponents on any of the given expressions.